In today's lesson, we're going to examine the things we looked at in our investigation and some of the big ideas we can use from that to help us do other things. And the idea in the investigation was looking at a form of a quadratic, one that had brackets in it. We call this our factored form. And something that we should know about is that each of the values, a, s, and t, which in most cases will become numbers. So for example, here, a is 1, s is that value, and t is this value. They all mean different things. That was part of our investigation. They did different things to our product. They may have moved it left to right. They may have made it open up or down. But we can figure out, just by looking at the equation and doing it really quick, some interesting things about this shape. So here's our big ideas. S and T, they're the x-intercepts of a quadratic. We also call those things zeros because they're the points where y equals 0. So if we go back for a second here, my zeros are -2 and -4. And remember, we always changed our sign when we took things out of a bracket. And the reason why is, if I were to put that number back into the bracket, so -2 plus 2, what's that come out to? 0. That's why I call it 0. Or -4 plus 4 comes out to 0. Why we call it 0. Okay, so those are our zeros, also called the x-intercepts. And you should know both words. The letter A determines the direction of opening. If you have a positive value, the parabola opens upwards. If A was negative, it would open downwards. So back to our example here, our A value is a +1, and my graph opens up. Okay, so there's 3 things I could find out really fast. A, S, and T. All I need to do is look at the equation and write them down. That'll tell me some really important things. Okay, so let's look at an example here. Examine the following parabolas and determine the direction of opening the zeros, the y-intercept, the axis of symmetry, and the vertex. So how can we do this? Well, let's look at the first one. Direction of opening. I need the A value. The A value is outside the bracket. It's a 1. In fact, it's a +1. So that tells me this opens up. A is +1. And it's really the sign that matters. The zeros. The zeros are from here and from here. So I change my sign, so -4, 0, and 2, 0. And I'm okay if you write them as brackets, or if you want to, x is -4 and x is 2. I don't care which version you use. The y-intercept. Now, the y-intercept is not something that you can look at the equation just write down. You actually have to calculate a y-intercept. But the nice thing about a y-intercept, and it's true for all parabolas, doesn't matter if it looks like this, if it looks like this, is this number right here, whatever dot that is 0 and something. So I know for the y-intercept, I can figure out what happens when x is 0. I use my equation, I put 0 in for x, and I do some BEDMAS. We'll get 4 times -2. My y-intercept is -8. That's pretty easy to find. And the axis of symmetry. We've talked about that. It's one of our special properties. We know our axis of symmetry is the midpoint of the zeros. Okay, so we can take our zeros, add them together, divide by 2. So we'll call this zeros. So let's give that a try. Our axis of symmetry will be x equals the zeros, -4 plus 2, divided by 2 comes out to -2/2, or in other words, -1. And if I know the axis of symmetry, the last thing I want to figure out is the vertex. Well, the nice thing is we can sub in the axis of symmetry. What does that mean? Well, if I take my equation is based on y equals x plus 4 and x minus 2. Equations are used to find points, right? Well, if x is -1, I can put it in for the x's and find the corresponding y. That's handy. That number is -9. So in other words, my vertex, called v, is made up of the x value of -1 and the y value of -9. And there's some basic properties you can figure out. I could draw it now. I could draw my zeros, my vertex. They have the direction of opening, all that good stuff, just by looking at the equation. Now we're going to try the next one. Same 5 questions. So part A, which way does this open? Well, here's my A value out front. Okay, so for part A, It's going to open down because A is -1. And again, I don't care about the number. It's all about that sign. Okay, part B, the zeros. Now this is a tricky one. Okay, this one, it's pretty easy to find the zero. What's the one over here? That's a special one. That's a zero of 0. Because if I were to put 0 back in that equation for x, if x was 0, well, x is 0 then, right? That's the whole idea why we call it 0. So I got 0, 0, and 6, 0. Be careful to change my signs. I don't have to worry about that when it comes to the 0, because 0 doesn't really have a sign, right? It's not positive or negative. Okay, part C, find the y-intercept. I know I can find the y-intercept if I make x be 0. Well, what happens if x is 0? I'm going to get -1 times 0 times -6. And anything times 0 comes out to 0. I found my y-intercept. It's 0. Just to point out to you, we kind of already knew that, right? One of our zeros happened to also be the y-intercept. Okay, part D. I want to find the axis of symmetry. I'm going to call that the AOS, okay? X equals, add my zeros together and divide by 2. So 6 over 2, which is 3. And then part E, find the vertex. I can do that by using my equation. My equation, oops, sorry, it's -6, right? My equation is this, but I know that x is 3 at the vertex. So I can plug in the 2 spots and get -3 times 3 minus 6. In other words, -3 times -3. And that comes out to 9. So I have a vertex of 3 for x and 9 for y. And it's pretty quick to do once we get the hang of this. It does take a little bit of practice, but those are kind of our 5 big important properties from factored form. Oops, wrong direction, sorry. Okay, what's something else that can happen? Well, we can change the A value. So A, the fact that it's positive tells me it opens up, negative opens down, but if I change the number of it, it actually does something else. We're going to examine each of these following quadratics to find their zeros and their vertex. Then we're going to make a sketch of each. I guess it's a good practice of what we just did. So our zeros. What are the zeros? They're -1, that's this one, and 3, that's this one. To find the vertex, I need my axis of symmetry. So I add them together, divide by 2, I got 1. To find my vertex, I got to find my y value. Plug in the axis of symmetry. So I got 2 times -2, which is -4. We can say the vertex is 1 and -4. Okay, let's do the next one. Zeros. The zeros come from here, -1, and here, 3. My axis of symmetry. Add them together, divide by 2. My vertex, y equals, oh, I got a 5 up front this time, so I've changed the A value. Notice that everything else has actually been the same so far, right? Same zeros, same axis, but something different is going to happen to the vertex this time, because I have to multiply that by 5. So 5 times 2 times -2, that comes out to -20. So my vertex used to be at 1 and -4, but by changing my A value, now it's at 1 and -20. I'm going to try the last one, the third one here. Hey, my zeros. Hey, those look kind of the same. -1 and 3. Which means if my zeros are the same, my axis of symmetry has to be the same. There's no choice on that, right? It's built on the zeros. My vertex. Let's see what happens this time if I make A 1/10. I'll get 1 plus 1 still, and I'll get 1 minus 3 still. Of 1/10 times 2 times -2. If you have trouble dealing with fractions, change the 1/10 to a decimal. 0.1 times 2 times -2. It's negative, and it's going to be a 0.4. So our vertex is 1 and -0.4. So let's sketch these things. We'll put them all in the same graph. Okay, our zeros. We were told our zeros were -1 and 3. So 1 and 3. And my first one had a vertex of 1 and -4, so halfway in between and down to -4. All right, so my graph would look like this. That's the first one. The second one had the same zeros, but because we changed the a value to a 5, our vertex went way down below. Now it's down here at 1 and -20. Okay. And the third one, same zeros. We change our a value to a fraction, a really small number. Now it's 1 and -0.4. That's right here. And that's that shape. So the a, by putting that number out front, didn't change the zeros, didn't change the axis. It changed the vertex by moving up or down, sort of. What it really does is it's stretching your parabola. The bigger the value, look at the green one, the bigger that a value got when we had a big number, 5, made it really vertically stretched. When we had a small number, 1/10, it actually squished it a little bit, it compressed it. So our other idea for a is, in addition to the sign, which tells us direction, the value tells us the size of our shape. Okay? A standard parabola has an a value of 1. If we make it larger than 1, we stretch it, and your parabola becomes narrower, like the green one right here. Okay, it got narrower because it got stretched. If it's between 0 and 1, in other words, if it's a fraction, a tenth, a fifth, a half, a quarter, something like that, it's going to be compressed, and it gets wider. And so let's take a look at this last example here. Given this equation, determine. Okay, now this is a bit of a weird one, because we've never seen a bracket squared. What does a bracket squared mean? What does 2 squared mean? That means 2 times 2. So sometimes we're going to come across weird equations where we have brackets squared. What that really means is you have to write out your bracket twice. That's what a bracket squared means. Write it out twice. There's 2 of them. So let's answer our questions, our basic properties. Which way does this open? My opening comes from my a value. So it opens up. A is positive in the 2. The size compared to normal. Oh, is it wider or narrower? That also comes from A. And this is going to be narrower since A is bigger than 1. And what that means is it's been stretched. When you stretch something, it actually becomes narrower. Okay, our zeros. So we know how to do those. We have x equals -2. That's, oh, sorry, not -2. -4. That's this first one. And, oh, I have the same number again. I have x is -4. And in other words, I don't actually have 2 different zeros. I have the same zero twice. We're going to see what happens with this. It's kind of something kind of cool here happens. Okay, D, our y-intercept. We know for y-intercepts, x is always 0. So let's figure out what we got. Y equals -2 times 0 plus 4 and 0 plus 4. Follow our BEDMAS. -2 times 4 gives us -32. Here's my y-intercept. Okay, E, the axis of symmetry. We'll put it over here so we can see it. Axis of symmetry is my zeros. This is AOS, okay, axis of symmetry. -4 plus -4 divided by 2. Well, that gives me -8 over 2, which is -4. It kind of should make sense. The average of -4 and -4 is itself, right? It's the same number. All right, last part, our vertex. We know we should be able to plug our axis of symmetry in for the x's. We're going to get 2 times 0 times 0, which is 0. So my vertex is -4 and 0, which looks suspiciously like my zeros. In fact, if I were to draw this, and I said I have zeros of -4 and 0, somewhere over here, and I have another zero of -4 and 0, and I have a vertex of -4 and 0, what that's really telling me is, and what else? We don't know it opens up, right? My picture has to look like this. The zeros are the vertex. That's a special kind of case. Doesn't happen very often, but the zeros are the vertex. Okay, so that's the end of the factored form stuff. There's big ideas in here. You should know about size and direction from your A value. You should know about your zeros from your S and your T. Average them to get your axis. Plug it back in to get your Y. And the special case there, a letter D, you should be able to figure out your axis of symmetry. Or sorry, your y-intercept. Okay, just plug in 0. Okay, some questions you should probably try to make sure you got this figured out. We're going to really start adding stuff in each day, so it's really important to be practicing this stuff as you go so it doesn't get overwhelming at the end.